Hello, hello. 2 years ago, I was at Movember with a big mustache, so this year is an improvement. Today I'd like to talk about DNSSEC. So the experience we've had at CIRA, and also I want to talk about how to get DNSSEC out there, get people to know more about it, actually use it, and implement out in production. So quickly about .ca, CIRA. So we operate the .ca domain name registry. We're the top level domain for .ca. So we run the registry, high availability infrastructure. We run the DNS for .ca, so we got name servers for .ca around the planet. Our goal is to have a available infrastructure for resolving .ca queries. And then I'll talk about how we implemented .ca in our DNS and registry. And the other thing we do is we do good stuff for the Canadian internet. So the money we make from .ca registration, we invest in the Canadian internet. So part of this is to promote IPv6 DNSSEC in Canada, to participate in various conferences and try to get people to know about the technology and get them to use it. And the other thing we do is we work on IXP development, so Internet Exchange Point. So in Canada, we've been working and deploying a couple of them in Winnipeg, in Montreal. So there's a couple of people from CIRA here. So if you want to talk about that, we're going to be here for the next couple of days to talk about Internet Exchange Point. But now I wanted to focus on DNSSEC. So for CIRA, implementing DNSSEC it's a three-phase process. Phase one was putting DNSSEC in our zone file. So that's called signing.ca. And it took us a couple of years to get that done. The issue with this was we're risk adverse. So we wanted to make sure we do it right with the solution that can support a new technology. So I'll talk about that a little bit. Second phase is to implement DNSSEC in the registry. So this is taking people that sign a second level domain, accepting the registration in our registry, and then putting that in our zone file. So there's a couple issues around doing this. There's a new aspect that I need to cover and make sure people understand. And the third phase is to get DNSSEC in to promote the adoption of DNSSEC. So this is doing like now, but more industry focused, talking to ISPs, talking to the banking environment, talking to universities and stuff, to get them to adopt DNSSEC in their current practice. So we'll start that next year, in our next fiscal year, in 2014, and build a plan to promote DNSSEC. So one thing we did with signing.ca is we had to develop technology internal to provide a high availability solution in signing our zone file. So if you do, you can search on the internet for DNSSEC and CIRA. You'll find a couple of presentations from that I did at ICANN meetings that's got details on technical architecture, how we actually signed the zone. But basically what we did is we have a solution with dual online signer. So because .ca, we need to make sure it's high availability. We signed the zone with one technology, bind, then we use a different technology, OpenDNSSEC, and then the output we compare to make sure that there's no bugs in either one that would cause our zone file to be invalid. So obviously the goal here is to produce on the internet a .ca that's signed and properly signed all the time. So we build a high availability solution where our backup site and our primary site are signing the zone file in parallel. Our solution is basically based on 5 or 6 years of experience with top-level domain operator on issues they encountered. So some of our peers, they put out a partial zone file, or they sign their zone file with invalid signatures. They all have different issues that cause operational outages. So our design tried to make sure that we actually produce the good zone file. So for the last 9 months, we didn't have any operational issues with our DNSSEC solution. The only problem is there's only 78 signed domains out of 2 million. So, and I suspect a good portion of the 78 domain are owners, registrant in this room. So outside, there's not a lot of adoption. So our goal is to increase that. So this is the technology to generate a signed zone with DNSSEC. DNSSEC in the registry, this is about getting, if one of you decide to sign your .ca domain, and you need to provide material to us to put in the zone file. And out there, I guess on a global basis, a lot of people are doing it differently. And it's causing confusion with adopting DNSSEC. So our key goal for CIRA was to develop a solution that was simple for a registrar to work with us. So when you sign a second level domain, there's a new piece in the puzzle that is showing up in different aspects of managing the life cycle of a domain with DNSSEC. There's a DNS Operator function. So in the past, you had the registrant that would want a domain. They have all the information they need to give us to create or register a domain. Now with DNSSEC, the issue is that once your domain is registered, on an ongoing basis, you need to have the DNS Operator, the entity that's responsible to manage the technical aspect of your domain, to create keys and to manage keys and to change keys. And the issue is that the DNS Operator is not necessarily the registrant. And and then I guess the industry, we're still trying to figure out how to make that work properly. So we have issues with domain transfer and so on. So the DNS Operator can be the entity managing the second level domain, the owner, or it can be a hosted company that manages the domain on behalf of the registrant, or it can be somebody, third-party entity, isolated from the registrant and the registrar. So we need to understand the impact of a DNS Operator, and it's touching how we implement DNSSEC in our registry for .ca. So if you look at this is probably as technical as it's going to get. There's a DNS key there. So basically, the DNS Operator, when they sign a second level domain, or third or fourth, they generate what we call a DNS key. So this is the key that you put in your zone file in the second level domain that is public to the world to validate that the information you provide is actually merging with the information you provide. The issue is that the parent, I guess the biggest issue with DNSSEC is the DS, which is a digest of your DNS key, has to be provided to your parent. So if you sign abc.ca, you publish a DNS key, somebody has to generate a DS record and put that in the .ca zone file. So you have to pass the baton from a child to the parent. So this means the DNS Operator is the entity that generates keys, the cryptographic material, and somehow through the registrant, through the registry, the information has to be passed. So I guess the industry are trying to figure out exactly how to make this work as seamless as possible. And the best practice for DNSSEC is that on an annual basis, you should change your DNS key. You need to roll over your keys. That means the DNS Operator needs to give the registrant the new key to be put in the registry. So that makes it a bit complicated, the ongoing process. So if you look at this, that's kind of a different way of doing it. But basically, you got the registrant on top with the DNS Operator and the information needs to go to the registrar. Then it goes to the registry.ca, and then we take that information and then we put it in the zone file. So between CIRA and our partners, which are registrars, that's super easy. We implement a protocol, RFC 5910. It's EPP extension, which basically allows us to accept material with the registrar. So that technology, we're going to have that available in March this next year. So we'll be able to interface with registrar to accept keys. The challenge is if you, as an operator or a web hosting company, the DNS operator, how do we get the keys to us through the registrar? Easy. So some people might do it differently. So the RFC says that you should be able to support either accepting DS information in the registry, or you accept DNS key, or you submit both. So and then what we decided to do at CIRA is to accept everything. So it doesn't, if you wanted to give us a DS or a DNS key or everything, we'll take whatever, make it super easy to work with, and not have a religious war on if we support DS or DNS keys or whatever. So we're going to build an interface to support every interface out there. So that's basically the approach that we're doing. That's going to be available in March. Some technical parameters will support up to 6 keys, pretty much all the protocols out there, all the parameters associated with RFC 5910 will accept in our EPP interface with registrars and our web interface. And the goal is to accept everything to make it easier for registrants to sign their zones and to work with our registrars. So the other thing I wanted to talk about is validation. So there's DNSSEC, there's 2 components to it. You sign your zone file. That means you put cryptographic material in the zone file to show that it's authentic. The second piece of it is the end user, the ISPs, the people using the internet, is the validation side. So actually taking the signatures and validating the information that's provided in DNSSEC. This is the document. That's the same document, Dan, right? That you have on your IANA website. So there's a document. I think version 3 is going to be the next one. If you go there, it's going to give you the information how to the relevant information for an ISP to sign or to validate DNSSEC in their infrastructure. So I tried to put in one page everything that DNSSEC touches, from a client, a website, recursive or iterative name servers, the root, TLD, second level domain. And basically, what I wanted to show in there is that for DNSSEC to work from end to end, everything needs to be DNSSEC aware. So your web browser, your operating system, the stub resolver you have, the recursive name servers, everything from A to Z needs to have DNSSEC, either assigning part of it or resolving part of it, enabled or available for all of it to work. So it's the evolution. DNS has been the same way for 25 years. DNSSEC is the future of the internet, along with IPv6. So everything over time needs to be upgraded and updated to support DNSSEC. So from an ISP point of view, the ISP is the entity responsible for a client in validating a DNS query. And so with DNSSEC, it needs to be updated with the latest, or not that latest, but a recent version of DNS to support DNSSEC. So Bind, Unbound, all of those, and even Microsoft, today support DNSSEC natively. So it's not new, it's available there. You just upgrade to the latest version, and it will validate DNSSEC today. The other thing you need to do, make sure you got the recent server. You also, DNSSEC, it does cryptographic signature validation. So you need to beef up your hardware a little bit. You need to beef up your bandwidth, and to be able to do that online. So in talking to Comcast, when they enabled their IPv6 and DNSSEC a couple of years ago, they said you're looking roughly 10% increase in hardware and bandwidth to support DNSSEC. So some papers talk about 100% increase or 1,000% increase. From experience, practically, Comcast is about 10%. And that I validated last week with them, and that's roughly the number. So today, I don't think it's an issue for any ISP to support DNSSEC. The other thing you need to do, so you upgrade your hardware, you need to upgrade your network to let large UDP packet flow up to 4K, and also UDP fragments with eDNS. You also need to support TCP, DNS over TCP, and there's also the negative trust anchor for broken sites. So what that is if somebody signs a domain incorrectly, you might have to configure your name servers to allow that domain to be resolved, even though it's been messed up by the DNS operator in terms of with signatures probably. So for the registrar that would like to have our information about our guide on how to implement EPP with .ca, it's available. Just let me know, I can send that to you. It's available in our .ca user guide or website. And well, if you have any question with DNSSEC, that's the email address to send us information. Questions?
Okay. Thank you, Jacques, for that. And questions for the audience. Do we have anyone here who'd like to ask Jacques some questions? How can he help you implement DNSSEC? Anyone here? Who's going to implement it first? Who's already got DNSSEC implemented in their validating resolvers in their ISP network? Okay. Anyone else? What's stopping you?
Can we do like raise a...
Here we go. Here, can you run?
Walking mic.
What's stopping me? So really it's because I don't know how to make it go. It's unclear. I've read a couple of tutorials and how-tos, but it's not clear, is it GoDaddy that I need to give my data to, or CIRA that I need to give my data to? I need to generate some keys.
Talk closer, again.
Sorry, so I don't know how to do it. That's the reason why I'm not doing it. I don't know how to do it. Okay. Do I need to talk to my registrar? Do I need to go to GoDaddy? Or do I need to, I can update my own name server, but then I need to start putting data elsewhere, to CIRA, to Tucows or OpenSRS or whatever?
So you're registrant, you got a .ca domain?
Right.
So you sign your own zone, you generate DNS key.
Yep.
And then you can, for now, until March, you can email it to us at this address, and then we'll authenticate you to sign your domain.
Right.
And then you'll be number 81.
Okay, that's
so
cool. Great.
But if you have questions, we have technical staff that can help you sign the domain. Or actually, IANA, they have a really good description on how to do that on their website,
Wonderful.
the ISOC.
Thank you.
So just to comment on that, though, too, there's two elements, right, to DNSSEC. One is what the gentleman was saying here about how do I sign my zone and get it out there. And that's the part you're talking about now, Jacques. The other part, though, is to enable the resolution within your networks. So that whatever DNS servers you're giving out to people on your networks, whatever those are, those validating resolvers, those are the ones that start to do DNSSEC validation. And Jacques put up a link, which we'll make available too, which is a really nice guide from the folks at SurfNet that shows how turning on DNSSEC validation inside of Bind and Unbound and Microsoft Windows Server 2012, it's really just a couple steps. It's even just, I think, one line in Bind's config file, for instance. So it's a very simple matter to do that, and then you start validating. You know, Comcast turned this on for their 18 million customers down in North America. Some of the other large ISPs are looking at doing it down there as well. In Europe, there's a good number of the ISPs have already enabled that there, and that validation is that first step that Jim was talking about earlier to make it to being able to do more of this. So one aspect is signing domains. The other aspect that you all as network operators can do is to turn on, enable DNSSEC validation on your DNS servers, on your caching DNS servers, on your caching resolvers, those things. And then that means that all of your customers will then be getting the benefits of DNSSEC as far as that security goes. I see a question over here. Actually, so this gentleman in the back there.
I almost laughed when you mentioned email the DS key to you. As DNS operators acting on behalf of many otherwise uninformed customers, let's say, what, I guess, authentication is in place to ensure that we're emailing you, I guess, the DS keys for the right domains? Can I email you the DS for google.ca?
No. No, it's a temporary measure until we have it in the registry with EPP and our registrar. So until you work with your registrars, then we accept it through a manual process, and then we have a authentication method we call, and we make sure you can, if you put it this way, if you can put a text record in google.ca to prove you can run the zone, then we'll add the DS. I doubt you can do that, but.
My name is Andrew Sullivan. So as an operator, I'm somewhat sympathetic to ISPs who may be sitting here and saying, what you're telling me is I have to spend money in order to increase my capacity 10% on my servers and on my bandwidth, and there appears to be no benefit for me in this. So let me just make an argument that there is in fact a benefit as an ISP to deploying validation on your servers, and that is that you can't be poisoned. So one of the key things that we've seen lately, of course, is that we've got a number of attacks against the network, and one of those is potentially that we're going to be sending people off to the wrong resources. If your customers go to the wrong place, that's going to redound to you, and you're going to have support costs. So there are support costs associated with DNSSEC because you're going to end up having when NASA screws up its signature once again on Mars rover day, you're going to get calls, and so you're going to want to have negative trust anchors, and there's operational cost to that. But if you are poisoned and you're sending all of your clients off to the wrong place and people get phished or whatever, you're going to have a bad day too. And so this is really insurance for your own network, and I strongly encourage you to look at it as a really cheap insurance against the attacks that we know are more and more pervasive.
So by a raise of hand, can you say which ISPs are planning or to resolve DNSSEC and not planning? Or so let's go planning. 1, 2, 2, 2.5. So not planning, like that's a deliberate choice of not doing DNSSEC in their infrastructure. 1. The rest is just education, benefits. Already deployed? 1. 2. Okay. So more education, I guess.
Hi, Paul Wouters, Red Hat. I just want to remind people here too, if you're running a resolver based on a modern operating system such as Red Hat Enterprise Linux or Debian or Ubuntu, be aware that validation is most likely already enabled and running for you because that's how modern OSs ship it out of the box. So many people here might actually be already running a validator without knowing that.
That's true.
Other questions, comments? Other questions or comments out here? Up over there.
Question about the DNS. Does it has another network linked to it, or can it affect linking with other network? That's one. Upgrades. Do we have an upgrade package for the DNS? Sometimes you start off single, you get a trial in certain networks, but we want to know if you're given a year, if there is a price after or.
I can't hear proper.
You can hear me? I'm
Talk
asking
loud.
because there's other network involved on the internet. Is there a problem connecting with the DNSSEC installation? And because there is a certification, is there a upgrade package? Like, can you start with a beginner, then you advance, middle, and then you get premium? Like you get silver, gold, platinum with a cost.
Oh, so if you're basically asking for there's costs involved in doing DNSSEC?
Yeah, if there's an upgrade.
So for .ca, we don't, for signing a .ca domain, we don't charge more. The DNS operator and the registrar might charge more for security because they're adding more features, so it might be more work on their side, so it might be a cost associated there. But you do get a more secure domain. But for .ca, we don't charge more. And for the rest, the software doesn't cost more to validate DNSSEC. It's part. Most technology today support DNSSEC validation.
Anyone else? We've got Jacques on stage. Put him on the spot.
More
DNSSEC
questions?
is exciting. DNSSEC is exciting. How you say it? Exciting? It's great. All right.
Okay, thank you.